So today we are going to start with module 2.6, that is measurement of power in a three-phase system using two wattmeter method. So please write down the topic. All right, you all ready? Okay, I'll tell you the things to write. Right now only write down the heading. So we'll discuss first some of the concepts related to power measurement. Okay. First of all, we'll start with the definition of wattmeter. Now, what is a wattmeter? Anyone knows? A wattmeter is an instrument, electrical instrument used for measurement of power. Now, which power we are talking about? Whether it measures active power, reactive power, or apparent power, we'll see now. Okay. So in a DC circuit, how is the power given by? Voltage into current. In a AC circuit, in a single phase AC circuit, it's given by VI cos pi, correct? And in a three phase AC circuit, we have seen root 3 VLIL cos pi. Yes or no? So this is the power measurement happening in a single phase circuit. So you have a current coil and you have a pressure coil. Here we have the AC supply, and this current coil and pressure coil comprises of a wattmeter. This is what the wattmeter contains. So internally, what does the wattmeter contains? It contains current coil and a pressure coil or a voltage coil, which will measure the voltage and a current and multiply and give it your power, active power. So write down the formula for power in a single phase system. VI cos pi. In DC it is VI. DC there are three formulas, V into I square R and V square by R. In AC circuit single phase it is VI cos pi. And three phase we have written last time, right? Root 3 VLIL cos phi. So this is how a wattmeter looks like. It consists of a current coil M and L and consists of a voltage or a pressure coil C and V. So these are measuring the current and voltage, and automatically your wattmeter will give you the active power reading directly. Okay. So this is not asked in the exam, but this is just to show you all key power. This is how the power measurement is done using a single in a single phase system. Nothing hard. Current coil measures the current, so it's connected in series, whereas pressure coil is connected in parallel for measurement of this thing. Okay, understood? Now this wattmeter has two coils, current coil and pressure coil. Your current coil has two terminals marked as M and L. M is mains and L is load. And your pressure coil has two terminals marked as C and V. C is the common terminal and V is the voltage rating. Okay. So what does it do? Current coil senses the current just like an ammeter in series with the load to carry the load current. And pressure coil senses the voltage just like a voltmeter connected in parallel with a load. Alright. So this current coil and pressure coil work together to give you current and voltage. Don't write this. Wattmeter reading depends upon its connection. So that means wattmeter senses the angle between the current phasor and the voltage phasor. Meaning it not only measures voltage and current, it also measures the phase difference between them. And what is the phase difference between current and voltage? Cos pi. So basically wattmeter measures VI cos phi. Are you getting it? The phase difference between the resultant voltage and resultant current also it measures. There are three methods to measure the power in a three-phase circuit. One is 1 wattmeter method, other is 2 wattmeter method, and third one is 3 wattmeter method. Now in our syllabus we have 2 wattmeter method because that is most used. Okay, so let's draw the power measurement scheme in a three-phase circuit using 2 wattmeter methods. So 2 wattmeter methods means what? 2 wattmeters will be connected to measure the power. All right. So draw the diagram, please, quickly. Draw the diagram quickly. This is 2 wattmeter method, and it's a straightforward, either a numerical or a theoretical topic will be asked. So very high chances this coming in exam is there. Almost every exam, every ESE exam, one question is there on wattmeter method. Either concept or numerical will be asked. So be very careful in this. So we have three phase R, Y and B. That means we have a three-phase star-connected supply, which I have not shown over here. Okay, which are my wattmeters? Where is my wattmeter over here? Okay, let me highlight it. This is wattmeter number 1. This is wattmeter number 2. We call wattmeter, name it as W1 and W2. See how they are connected. Current coils are connected in series. Upper one is the current coil and pressure coils are connected in parallel. It's not at all hard. You have to just draw it carefully. First, draw the three-phase star-connected balance load, balance system. So this is my three-phase system, which we have seen before. It's a balance load means what? All of the three arms are same. Z phase, Z phase, Z phase. We have a line voltage and a phase voltage. And we have three currents, IR, IY and IB. What is Z phase called as? Impedance of each coil. W1 and W2 are 2 wattmeters. So see how they are connected. First you draw the current coil, okay. Then at the end you draw the pressure coil, voltage coil. And if you see carefully, voltage coils are connected together. One end is connected together, and the other end is connected to the respective phases R and B. So 2 wattmeters are connected across two phases R and B. So that's why it's called as a 2 wattmeter method. Okay. Here, just listen till the time you draw. Completed drawing. So we are assuming a lagging power factor. What do you mean by lagging power factor? That means your load, which is Z phase, is inductive load. Okay, it's a RL load. We have not shown it, but whenever we have a power factor lagging, that means it's a RL load. And N is the neutral point. Completed all of you? Can we proceed ahead? Okay, see carefully how they are connected, and you have to circle it and show that this is W1 and W2 when you write. Okay. So the magnitude of each phase is same over here. V phase, that is, what are the three phases? VRN, VYN, VBN and V phase are all same. Three phase currents are IR, IY, IB. They are also same, equal to I phase. Okay. Now, actually, I'm not showing you how to draw this diagram. Partly the diagram has already been covered in your star connected system. Okay. So I'm just showing you all how to draw it in a 2 wattmeter method. Okay. Now remember VRY. What is VRY? Line voltage or phase voltage? Line voltage. Because VRY is what? VRN minus VYN. So instead of writing minus VYN, can you see this, whatever written over here? No? Let me highlight. Can you see this? No? Okay. So this is basically V R Y. You can write this thing is equal to V R N. Actually, we can write minus V Y N, but we have written V N Y. Okay. And here it is V B Y. This is line voltage is V B N. We can write minus VYN, instead we are writing plus VNY. So with the help of this, we can draw the diagram. So how to draw this? How to start? What is the starting point? What you will do first? First, you will draw RYB. What? Phase voltages. Okay. So the first thing is, don't draw this. You can later on at home and practice it. Don't draw it right now. So first thing you do is, let me write over here. First, you draw VRN, VYN, and VBN. What are these things? These things are phase voltages differing from each other by 120 degree. Understood? Now you draw the mirror images of them. Now actually we have two voltages only, line voltages VRY and VBY. VRY and VBY, because we have two wattmeters only. Alright, no need to measure the third one. So we have VRY. What is VRY? VRN plus VNY. Now, we know what is VYN, right? So draw the mirror image VNY. So second step is draw the mirror of VYN, which is VNY. All these are bars, okay, vectors. And also draw the mirror image of. You require any mirror, anything else mirror image? No, basically not required. So draw the mirror image VNY. Okay. Now, what is VRY? According to the law of parallelogram, it should be VRN plus VNY. So where is my VRN? This is my VRN. See over here. This is my VRN and this is my VNY. So the resultant will be VRY. Law of parallelograms, you can do it over here easily. So this is my resultant vector VRY, which is the line voltage. VRN and VNY are the phase voltages. Got it? This we have already covered while drawing the phasor diagram of star connected system. Now, next is VBY, is VBN and VNY. So VBN is over here, VNY is over here. So VBY will be the resultant, the parallelogram, resultant of the two. So here we have VBY. Okay. Now, since the power factor is lagging, the current will be lagging behind the voltage. So I have drawn over here three currents, IR, IB and IY, which are lagging behind by the phase angle of phi. So next you draw, I am drawing the sequence, then you draw the resultant VRY and VBY. So these are the resultant line voltages. Then you draw IR, IY and IB currents. Alright. Now, listen carefully here. The phase difference, the phase angle between a line voltage and a phase voltage is how much? Last time we have seen previous two lectures, 30 degrees. Line voltage and phase voltage in a star connected system is 30 degrees. And let me concentrate, let me show you over here. So this is phi. What is phi? This is the resultant current and this is my resultant phase voltage. So their phase difference is phi. Now if I want to measure current between this IR and VRY, how much it is? This 30 plus phi. Got it? This you have understood? Entire derivation is based on this phasor diagram. Then again, the phase difference between VBN and IB is how much? Phi. Okay? And here, the phase difference between IB and VBY is how much? This is 30, this is phi. So it will be 30 minus phi. You understood why it is 30 minus phi and why that was 30 plus phi? Only this much information is required, that's it, using two wattmeter method. And why we are not drawing the third resultant diagram, third line voltage? Not required. For measurement of two wattmeters, we only require two voltages, which are line voltages, which are VRY and VBY. Are you understanding? Alright. And if you see carefully, V and Y is common between the both because of the neutral point. Got it? This you have understood? This 30 minus phi and 30 plus phi, how it came? Yes or no? Okay. Now listen carefully. And these are the steps to draw the phasor diagram. You have to draw it. So leave some half a page space and write down these things. So from the phasor diagram, the wattmeter 1 reading is given by. Normally wattmeter will measure VI cos phi, na? One phase system is VI cos phi, right? And what is W1 connected between? W1 is connected between V, R and Y. See? VRY, na? W1. So it is VRY into IR into cos of angle between VRY and IR. Correct? So write down W1 is VRY into IR into cos of angle between VRY and IR. Now what is the angle between VRY and IR? VRY and IR. How much it is? 30 plus phi. Okay. So in the next diagram, the angle between VRY and IR is 30 plus phi. So W1, the wattmeter 1 reading will be VRY into IR cos of 30 plus pi. At least write this down, equation number 1. You all have understood how does this come? See, the reason why you concentrate over here is because at the end you have to study this alone. So when you go home and when you read the same topic, it should be easier for you to understand. That's the only thing you concentrate in the class for. If you don't understand, you start leaving the topics. So I hope you have understood this. 30 plus 5 kaise aaya? Alright. Next, wattmeter 2 reading W2 is given by VBY and IB. So let me show you wattmeter 2 VBY, correct? Line voltage VBY it measures. So VBY into IB into cos of angle between VBY and IB. So let me show you the angle between VBY and IB. So VBY and IB is 30 minus 5, which we have shown already in the phasor diagram. So here you can write it down. The angle between VBY and IB is 30 minus 5. So W2 is VBY IB into cos of 30 minus 5. At least write equation number 2 now in your books. Remaining things, if they ask you in the exam, you have to explain everything. So W2 will be VBY IB cos of 30 minus 5. Completed? Yes or no? Now listen carefully. In a star connected system, my load current, my phase current and load current are same, or phase voltage, phase current and line current are same, sorry. Okay, so we can write VRY as VL because all the line voltages are almost same and all the phase currents are also same. So IR is equal to I phase is equal to IL and VRL is IL, VL. So W1 is VLIL cos 30 plus 5. So rewrite the formula. Similarly, W2 will be VLIL cos of 30 minus 5. Okay? Because phase current is same as line current and phase voltage is over here the line voltage we are determining by VL. Alright? In a star connected system, phase current and line current are same. And here VBY and VRY are the line voltages. So W1 is VLIL cos 30 plus 5. W2 is VLIL cos 30 minus 5. Written equations. Call them 3 and 4. Now you add 3 and 4. So this I leave to you as an exercise. But here I am showing you all how it's to be done. So W1 plus W2 will be VLIL cos of 30 plus 5 plus VLIL cos of 30 minus 5. So basically VLIL you take common. You take cos of 30 plus 5, cos of 30 minus 5 and you know the trigonometric formula. Okay. So it will be twice cos 30 cos A cos B. Cos A cos B here. It will be cos of A plus B into cos of A minus B, right? So it will be twice divided by 2. So it will be twice cos 30 cos pi. Are you getting it? Now what is cos 30 root 3 by 2? So VLIL twice root 3 by 2 cos pi. So finally what do you get? W1 plus W2 as root 3 VLIL cos pi. Is this the same formula for measurement of power in three-phase circuits? Yes. So W1 and W2 is VLIL root 3 VLIL cos pi. Write it down please. Write it down. Note it down please. Completed? Okay. And what is power measurement? W1 plus W2. Why wattmeters now? There are 2 wattmeters. One wattmeter is reading W1 reading, other wattmeter is reading W2. What do we do? Add the 2. So power is W1 plus W2. Also write this down. Power is W1 plus W2. Now remember, in this equation number 5, the right hand side is the active power in a three-phase system, right? Yes or no? Or it is root 3 VLIL cos pi is active power, no? There are 3 types of power: active, reactive and apparent. So this is a reactive power. So therefore it is proved that when 2 wattmeters are connected as shown in the circuit diagram as we have shown, The algebraic sum of the two wattmeter readings gives the total power consumed in a three-phase system. Do you get it? Meaning the active power is root 3 VL cos phi. Now, if you connect the two wattmeter methods, connect the measure the power using two wattmeter methods, what you need to do is just add W1 and W2 reading. That will be same as active power of the circuit. Okay, this is root 3 VL cos phi. All right. So, therefore, in a two wattmeter method, the addition of two wattmeter readings gives you the active power of the circuit in a three-phase circuit. Is this understood? Yes or no? So basically W1 plus W2 is equal to P. That is what we have proved over here. Alright. Next is we subtract the two the readings because we need to calculate phi now. So W1 minus W2. Similarly, it will be root 3, not root 3, VLIL cos of 30 minus phi minus cos of 30 plus phi. So that will be sine A, sine B. So it will be W2 minus W1 will be VLIL twice sine 30 sine phi, and sine 30 is half. So W2 minus W1 is VLIL sine phi. Please write it down. W2 minus W1 is VLIL sine phi. Okay. Now what do we do is we multiply both the sides by root 3. So root 3 W2 minus W1 is root 3 VLIL sine phi. Now what is root 3 VLIL sine phi? Reactive power. Correct? So Q is root 3 W2 minus W1. So if you want to find the reactive power, it is root 3 times W2 minus W1. Okay? Active power is what? W1 plus W2. But reactive power is root 3 W2 minus W1. Alright? Completed? Okay. Now what do we do is, we divide equation number 7 with equation number 5. Okay? What is equation number 7? Root 3 W2 minus W1 is root 3 VLIL sine phi. And what is equation number 5? W1 plus W2 is root 3 VLIL cos phi. So when we divide the two, what do we get? Sine phi upon cos phi is what? Tan phi. Correct now? So what is tan phi now? Root 3 W2 minus W1 upon W1 plus W2. So what will be phi now? Tan inverse of root 3 W2 minus W1 divided by W1 plus W2. Write down this formula. This is the formula for calculating the power phase angle phi. I just explained all the steps how we got this. You have to write it down and refer it once more. Now remember, you won't get the phase angle negative. So basically, W2 will be greater than W1 in terms of values, whichever is the greater. Completed? Written the formula of phase angle. Now, written this formula tan inverse of root 3 W2 minus W1 upon W1 plus W2. Now, in general, listen carefully. For both lagging and leading power factor in general, phi will be tan inverse of root 3 higher reading minus lower reading. What do you mean by higher reading? Out of W1 and W2, two wattmeters, whichever is showing the higher value, that will be the first one, minus lower reading divided by higher reading plus lower reading. Are you getting it? And higher reading is always positive, whereas lower reading can be positive or negative. Are you getting what I'm saying? Yeah. What are the advantages here? This general formula, remember it, okay? This will be helpful while solving the numerical. Now, what are the advantages of two wattmeter method? They also can ask you in the exam. So the first advantage is it is applicable for both balanced as well as unbalanced load. What do you mean by unbalanced load? This, whatever I have discussed, is helpful even for your lab quiz because all the concepts are covered over here. So all the questions can be asked from here also. Now, what do you mean by balanced load? That R phase of all the three phases are same. If any one of them is different, it is unbalanced load. So from the wattmeter reading, you can calculate the active power, reactive power. Now, if you have a wattmeter in the lab, you will be doing this experiment. That wattmeter cannot measure reactive power. It only measures the active power. You're built for active power. Whenever your energy meter is making the reading, you're built for active power, not reactive power. It's already considered into it. So From this wattmeter reading, you can find reactive power. How you can find reactive power? Root 3 W2 minus W1, right? That is the formula. Now, if the load is balanced, not only the power but also the power factor can be determined. From this method, you root 3 VLIL cos phi is determined automatically, right? Then, neutral point for star connected load is not necessary to connect the wattmeters. So that's another advantage which we have over here. So these are all the advantages of two wattmeter method. Have you understood the technique? You have to draw the circuit diagram, write down the line voltages and phase voltages. Line current and phase currents are same. Then draw the phasor diagram. From the phasor diagram, determine W1 plus W2. That should be equal to active power. Then determine the formula for the active power. Then determine the formula for phi. All right. So only very small topic is there and it's very important. All right. So next, can we start with the numericals? Numericals are already said with you. So open your numerical page and let's start solving numerical number 1. And they do come in exam. If you check any old paper of EEEE, every time there is a numerical on two wattmeter method or a theory question is there. So let's start. Do not write a numerical, it's already been said with you, everyone. Did you receive it? Yeah. So you can write solution for numerical number 1. So let me start straight away. Two wattmeters are used to measure power in a three-phase balanced load. So find the power factor if two wattmeters are equal and two readings are equal and opposite. Two readings are equal and positive. One wattmeter reads 0. Okay, one of the wattmeter reads 0. So how will you solve this? So what is the meaning of two readings being equal and opposite? Meaning W1 is equal to minus of W2, correct? Can you see the red color over here? Okay, what is the meaning of two readings are equal and positive? All right, and what is the meaning of one wattmeter reads 0? You can consider W2 is equal to 0. We have to find the power factor. What do you mean by power factor? Cos phi in all the three cases. So let's start with the first case. What is the thinking process? Only these two formulas are required. Phi will be tan inverse of root 3 times W1 minus W2 upon W1 plus W2. Here we are assuming W1 is greater than W2. That's why I have written W1 minus W2. Don't worry about it. So let us start solving the solution. So for the first case, W1 is same as minus of W2. So what will be phi given by tan inverse of root 3 W1 minus of W2 divided by W1 minus W2. Okay, so phi will be tan inverse of infinite, right? Because W1 minus W2 are same, right? So they will be 0. So what is tan inverse of infinite? 90 degree. Tan 90 is not defined. If you check in your calculator, what is the meaning of not defined? Means its angle is 90 degree. Okay. So what will be power factor over here? Cos of phi. And what is phi? 90 degree. What is cos 90? 0. So whenever the two wattmeters are equal and opposite, the power factor is 0. Is power factor 0 very good? Very bad. Okay. Write this down. Note it down. Can we go for the second case now? Completed this? So let's go for the second case. For the second case, both the wattmeter readings are equal and opposite and positive. So W1 is equal to W2. So find phi now. Phi will be tan inverse of root 3 W1 minus W2. This is the formula. W1 plus W2. So what will happen if both are same? it will be tan inverse of 0, right? Why 0? Numerator cancels out because W1 is equal to W2. So phi will be tan inverse of 0. What is tan inverse of 0? Phi will be 0 degree. Okay. And if phi is 0, what is power factor? Cos of phi, which is cos 0, which is 1. For the second case, the power factor is 1. Please write it down. I hope you're following this. Yeah, I hope you are able to understand. W1 is equal to W2. So numerator will become 0. And tan inverse of 0, the angle will be 0 only. For the third case, do it and tell me. Is this complete? Third case may assume W2 as 0 and solve. So for the third case, let's say W2 is 0. So phi will be tan inverse of W1 minus 0, W1 plus 0. So what you will get over here? Tan inverse of root 3. Okay. What is tan inverse of root 3? Phi will be 60 degree. So what will be the power factor now? Cos of phi, which is cos of 60 degree. What is cos 60? 0.5. Now you will be questioning over here why we are writing W root 3 W1 first. We remember the general formula, whichever reading is higher, that we write first. So it does not depend upon W1 or W2, it depends upon which is the higher reading. Understood this type of numerical? They can ask you power factor and the readings of 2 wattmeter will be given to you. Completed this? Everyone is able to complete? Next, please listen carefully. 2 wattmeters are connected to measure power in a 3-phase circuit using 2 wattmeter method, indicating 1250 watts and 250 watts respectively. So what will you consider 1250 as? W1, the higher one, and the lower one will be W2. Find the total power supplied and the power factor of the circuit when both the readings are positive. What do you mean by both readings positive? W1 is and W2 is 250 watts. Both are positive. Then when the later reading is obtained by reversing the connection of the pressure coil. What is the meaning of this? When the later reading means W2 is minus by reversing the connections of the pressure coil. Reversing the connection of the pressure coil matlab voltage is reversed. So wattmeter reading will be negative. So later reading means W2 is minus 250 and W1 is same 1250 watts. Okay, this is the given data. So W1, W2 are given. We have to find total power supplied. So what will be total power supplied in both the cases? What is total power supplied? Simple, right? Power supplied in a 3-phase circuit will be addition of the wattmeter reading. So write down. You have understood this? Both readings are positive. Later reading is obtained by reversing the pressure coil. That means it's negative. So this is negative over here. So let's start solving. Remember phi will be tan inverse of root 3 higher reading minus lower reading. Huh? This you need to remember it. And power factor is cos phi. Only these two formulas are there. So let's find out the first one now. First we have to calculate the total power. The total power in a 2 wattmeter method is W1 plus W2. So 1250 plus 250 watts. So how much is that? 1500 watts. No sweat. You have already got the answer. Next, you need to find the total power supplied and the power factor. When? So whenever both the readings are positive, calculate the power factor. So power factor we require 5, so that will be tan inverse of root 3 W1 minus W2 upon W1 plus W2. Okay, now tell me what is W1? 1250, W2 is 250, and these together are 1500. Yes or no? So 5 will be tan inverse of root 3 times 1250 minus 250 is 1000, and this will be 1500. So you can cancel out two zeros. So this will be actually, if we calculate, it will be 2 by root 3. And tan inverse of 2 by root 3, if you do, you'll get 5 as 49.1 degree. You can check your answers. Check your answers, please. So power factor will be cos of 49.1 degrees. That will be 0.655. You're getting this? Same? Okay. This is for the first case, where W1 and W2 are equal and positive. Okay. For the second case, what you will do? Same thing. Can we start with the next one? For the second case, W1 is 1250, W2 is minus 250. So repeat the same thing for case number 2. Are you following? Okay. So let's see. So for case 2, W1 is 1250 watts and W2 is minus 250 watts. So what will be the total power consumed? How much that will be? 1000. Understood? Now calculate phi tan inverse of root 3 W1 minus W2. So what will be this? This is 1250 and this is minus 250. W1 plus W2 is 1000. Remember, they will get added up. Okay? So you'll get tan inverse of root 3 1500 divided by 1000. Alright? So that will be, phi will be tan inverse of 3 root 3 by 2. So calculate phi, 68.94 degrees. Can you cross check? So therefore power factor will be cos of 68.94, which will be 0.359. Power factor doesn't have a unit. Did you get the same answer? Okay, great. These actually, if you see, the numerical statements are big, 3-4 lines, but the answers are very simple. Not much sweat is required, whereas we have solved tougher numericals in this. Okay? Can we go on to the next one? Completed this? Okay, fine. Numerical number 3. Everyone pay attention, please. Don't lose focus. Any numerical can come in exam, and it can save and give you those 10 marks, vital 10 marks. Okay. So the power in a 3-phase circuit measured by 2 wattmeters. So if the total power is 50 kilowatt, power factor is 0.6 lagging, find the reading of each wattmeter. So what they are giving? They are giving total power, P. They are giving power factor. We need to find the reading of 2 wattmeter. Matlab, we need to find W1 and W2. Are you getting what I'm saying? So let's start. So what is the total power given to you? 50 kilowatt. So 50 into 10 is to 3 watts. What is the power factor given to you? 0.6. And we need to find the reading of the each wattmeter. That means we need to find W1 and W2. Remember carefully, whenever the numerical statements are very less, there are 1 or 2 lines, those numericals are tougher numericals. Wherever the statements are big, there's actually a lot of information is given to you. Okay. So only this much is given, we need to find W1 and W2. How do we proceed? First, write down what is given to you. So power is, by 2 wattmeter is W1 plus W2. Please start writing along so that you don't lag behind. 50 kilowatt. Let's call this equation number 1. There are 2 unknowns, W1 and W2. And how many equations we have so far? Only 1. We require 1 more equation. Okay. So what else do we know? What else is given to you? Power factor. So power factor is cos phi. So that means 0.6 is equal to cos phi. So what will be phi? Cos inverse of 0.6. Calculate how much that is. 53.13. So we got the value of phi. Yeah, please pay attention. Okay. We got W1 plus W2 equal to 50 kilo. We require 1 more equation. So basically we require W1 minus W2. So now, what is tan phi? See, phi is tan inverse of. So what is tan phi? Root 3 W1 minus W2 divided by W1 plus W2. Do we know the value of tan phi? Yes. Tan of 53.13 is multiplied by, we cross multiply, into W1 plus W2 is equal to root 3 times W1 minus W2. Do we know the value of W1 plus W2? Yes. How much is that? Yes or no? So from here calculate W1 minus W2, which will be tan of 53.13 degrees into 50 into 10 raised to 3 divided by root 3. So tell me this number. Is it 38.49 kilowatts? Yes. Got the value? 38. Now we required, now we have W1 plus W2 is 50K and W1 minus W2 is 38.49. How do we calculate next now? Equation 1 plus 2. So W1 plus W2 is 50 into 10 raised to 3. W1 minus W2 is 38.49 into 10 raised to 3. So if we add them together, what you will get? Twice W1 will be 88.49 kilowatts. So what will be W1? Half of it, 44.245 kilowatts. Okay. Then how do we find W2? W1 plus W2 is 50. So W2 will be 50 kilowatt minus W1. So this is how we got the wattmeter reading of both the wattmeters. Understood? Pretty easy, only 2 formulas are there, that's it. Completed? Now we go for the last numerical for the day. Alright? Yeah? Okay, let's start. Now listen carefully. Each phase of 3-phase delta connected load has an impedance 50 angle 60 degree ohms, the line voltage is 400, calculate the total power. What will be the reading of two wattmeters connected to measure the power? So it's slightly, more detailed information is given. Remember, in a delta connected system, phase voltage and line voltage are equal. Okay, and so here we have been given Z phase and line voltage. So let's go by the thinking process. What we need to find? Power, total power, and we need to find W1, W2. Okay, so the thinking process goes as follows. In a delta connected load, phase voltage and line voltage are same, and phase current will be phase voltage divided by Z phase, and the line current will be root 3 times I phase. This is the relation between the two. The power will be root 3 VLIL cos phi, and what will be the reading? W1 and W2. Remember, we have calculated now. W1 is VLIL cos of 30 minus phi, and W2 is VLIL cos of 30 plus phi. Reverse or opposite are also true. We have written W1 is equal to VLIL cos 30 plus phi. So that's fine. Did you understand? So these are the simple steps we need to calculate. Okay. So let's start. First, write down the given data. So the first step is the given data Z phase. How much it is given? 50 angle 60 ohms. Now tell me what is phi? Z phase, and what is 50 Z phase and what is phi? 60 degree. So from here we get the value of phi as 60 degree. Acha, what else is given to you? VL is 400 volt. Yes. Now in a delta connected load, you can write it down. In a three phase delta connected system, V phase is equal to VL is equal to 400 volts. So secondly, I phase will be V phase upon Z phase. What is V phase? 400. What is Z phase? 50. Okay. So what will be the phase current? 8 amperes. 400 upon 50 is 8 amperes. Now calculate line current. In a three-phase delta connected system, line current is root 3 times phase current. Last lecture we have compared star connected and delta connected system. So it will be root 3 times 8. That will be 13.86 amperes. Please write it down. Next, the active power is root 3 VLIL cos phi. So we now have the value of VL, which is 400, IL, which is 13.86, and cos phi, which is cos of 60 degree. So calculate the value of active power P. Wait. 5 minutes, you can't wait. Root 3 VLIL cos phi. How much is this? 4.8 into 10 raised to 3 watts, right? 4.8 kilowatts, is it? Are you getting these answers? Okay. Now, the reading of the two wattmeters, assuming W1 is greater than W2. So what will be the formula over here? So assuming so assuming so what are the formulas? VL IL cos of 30 minus 5, VL IL cos of 30 plus 5. So please calculate. 5 is how much? 60. So 400 into VL is 400, IL is 13.86 into cos of 30 minus 60. So cos of minus 30 you will get, which is 4.8 kilowatts. And here you will be 400 into 13.86 into cos of 5 is 60. So this will be cos 90. What is cos 90? 0. So 1 wattmeter reading is showing 4.8 kilowatt, other is showing 0, and the total power is how much? 4.8 only. Write your roll numbers here. Understood everyone? 2 wattmeter readings are 4.8 kilowatts. So 1 wattmeter is reading showing 4.8 kilowatts, other is showing 0. Okay? We have solved 4 numericals. We have 2 more. One is homework and one I am going to describe it. Don't write it. Sign. Okay? So, just listen, don't write it. You can refer it later. We have less time now. The reading of the 2 wattmeter connected to measure the total power in a 3-phase star connected 400 volt system are 3000 and 5000. So, the line voltage is given as 400 and the power ratings are 3000 and 5000. How do we solve this? We need to find the power factor, total power and line current. So, what is total power? W1 plus W2. What is W1 over here? 5000. W2 is 3000. So what will be total power? W1 plus W2. Right? Power factor, how will you find? Find phi. Tan inverse of root 3 W2 minus W1 upon W2 minus W1. So power factor will be cos phi. Power will be W1 plus W2. How will you find the line current? What is power given by? Root 3 IL cos phi. You know power. P you know, right? You know root 3 VL you know, right? IL you can find out. So IL will be power divided by root 3 VL power factor into power factor. So in this way you will write the answer. So note down the answers please. So you will get total power as how much? 8000. Then you will get the value of phi as 23.41 degrees. Then you will get the power factor as 0.917. Then you will get the current as IL as 12.58 amperes. So these are all the answers. Okay, I hope you can solve this now with the enough information given to you. And one more numerical is there for you all to solve it by, you can read this and solve it on your own. So these I leave up to you to solve this on your own. All right. Now, yeah, that's it for today's lecture. With this, we have completed module number 2, that is AC circuits. Okay. Next time we'll start with module number 4.